Hi everyone, welcome back to my channel. This is Rahul. If you are preparing for coding interviews, you are in the right place. Today we are solving a medium level problem called Map of Highest Peak from LeetCode. This is a grid based problem involving water and land cells, and we need to assign heights to the cells based on certain rules. Let's dive into the problem. So, here is the problem. We have a grid is water where size m into n and 1 represents water cells and 0 represents land cells. Water cells must have a height of 0 and heights of adjacent cells can differ by at most 1. So our goal is to assign heights to all cells such that the maximum height in the grid is maximized. So let's get into the coding part. So here we have our method ASPeak which takes two-D grid called matrix, and we need to initialize two variables in order to get the length. So I will name it as m, and then is water node length. Same like we have to take for n water of 0 dot length. Then we need to assign one value, which is a large number used as initial value for uncalculated heights. So I will give Maxwell as 2000. So now we are going to start our loop where we initialize water and land heights. So let's start for int r equal to 0, r less than m, and increment r. Then again another for loop, int c equal to 0, c less than n, same increment. Then the water cells are converted to height 0 because the height is fixed. So let's do if is water of r c equals 1, then is water r c equals 0. Like that, the land cell are temporarily set to 1. This helps us differentiate the land cells from uninitialized cells in the upcoming step. Else is water c 1. Now we need to calculate heights from top left. So for that also we will use one loop, same like this only because it's a 2D matrix for int r equal to 0, r less than m, then same increment r. Again for c C we have to initialize C equal to 0, C less than n, C plus plus. So here we have to only process land cell at first. If is water C not equal to 0. So here we iterate from the top left corner to the bottom right corner. In this one we have to initialize two variables for top neighbor and left neighbor. So I will name it as int top and assign Maxwell. We already assigned it here. Same for left Maxwell. Then we need to for each cell we check its top and left neighbors. So if the neighbor exists, their heights are considered. If minus 1 greater than equal to 0, then we have to update top is water of r minus 1 c. Like that we have to check if uh, the left one also exists. If c minus 1 greater than equal to 0, left is water r c minus 1. Then we need to set height based on neighbors. So here the height of current cell is we will set to the max one from the top left is water r c mat dot min in this top and left we have to give plus 1. This ensures that the height difference between adjacent cells remains within the allowed range. So after this step, every land cell has an approximate height based on its top and left neighbors. However, we have only considered half the grid, so the values aren't final yet. Now we need to adjust heights from bottom right. So let's start from second loop for int r equal to m minus 1 or greater than equal to 0. Then decrement r. Then same we have to do for c n minus 1 c greater than equal to 0 c minus minus. Then we need to only process the answer like before only we have to do So here we take minimum value between the current height and the height based on the bottom and right neighbors. So like before we have to take the we need to process only the land cells. So if is water RC not equal to 0. Like before we have to initialize two variable which is the bottom neighbor and right neighbor. So simply I will name it as bottom and right and assign value maxval int right equal to maxval. Then like before we need to check if bottom neighbor exists like that. Then we have to check for um, right neighbor. If r plus 1 less than m, then we have to update bottom variable r plus 1 c. Same we have to do for right variable c plus 1 less than n. Right equal to is water r c plus 1. Then we need to update them our matrix is water r c equals we need to get the mean at dot minimum of uh, is water r c and the bottom right. So this ensures that all directions are taken into account and every height follows the rules. Now nothing. We need to return the our matrix. So finally we return the updated is water matrix which now contains the assigned heights for all cells. Right, just run it. Where okay. Yeah, it's working. So I will show you one example here. This one. So here our matrix is water is 0 1 0 0 and output 1 0 2 1. So how it is? I will just mention it by step. First of all, we will start by marking water cells as 0 and land cells as 1. So it is 1 0 1 0 1 1. In that way, first bus top left to bottom right. So at that time 1 0 and 2 1. Second bus bottom right to top left. Then the matrix after update same 1 0 2 1. So as you can see, the heights follow all the rules. Water cells are 0. Heights differ by at most 1 between adjacent cells. The maximum height is maximized. Let's submit it. Yeah, it's almost beats. So that's it for today's video. We have successfully solved the map of highest peak problem step by step and implemented a dynamic programming solution that works efficiently. If you found this video helpful, please like, share, and subscribe for more coding tutorials. And don't forget to leave a comment below if you have any suggestions or questions. Thanks for watching and see you in next video.